Alrighty, y'all. I got it. Let's look at this bell work. What are we gonna do here? Thank you, my dear. What do we do here? Factor. We need factor at the top and factor at the bottom. And I'm gonna mark this so I don't forget. There we go. Sweet. So we're gonna take the top and we're gonna factor it. What goes at the top of our little X frame here? -10. And what goes at the bottom? -10 and -3. What's a pair of numbers that multiplies to make -10, adds to make -3? -5 and +2. Since I have an A value that is not 1, we are going to need to box this. So, bring it down here, and I'm right at the very bottom of the screen, but that's okay. So we're going to take our 2x squared and our -5 from our equation. And then we take our -5x and our +2x from our X frame, and we pull our factors. What do we get as factors for this green function? Yeah, we've got x and +1 and 2x - 5. So our factor form is x + 1, 2x - 5. Then we get to do the same process with our denominator. Same thing. We're going to X and box it. Top of my X goes what? -20. And the bottom goes -1, which means my pair of numbers is -5 and +4. Again, my A value is not 1, so we are going to do the full box. So we've got our 2x squared and our -10 from our equation. And we get our -5x and our 4x. And we're going to pull our factors. What are our factors here? X + 2 and 2x - 5. So it's a whole lot of work for us not being done yet. What do we need to do to finish this guy out? So we've got our 2x - 5 on both top and bottom. So this one cancels out and that one cancels out. And our simplified answer is x + 1 over x + 2. That's our answer right there. The simplifying is going to come back into play on Monday, Tuesday, Wednesday. We're going to use it with our graphing stuff that we started doing yesterday. Today we're going to, for realsies, graph 4, 5. Okay? So, I only have 3 on my thing, so we'll see which ones I don't have up here and do it hard way. Okay, so up here on the screen, I have a refresher of what you guys had on the first day. Yesterday, we talked through this. Our transformation form. I highly recommend you rewrite our transformation form at the top of your page 4, the Graphing Rationals, day 2. Put our y equals a over x minus h plus k. Put it there. Because we're going to use it. This is number 2. I love that for me. What is going on here? That's not the right one. All right. I love this. So much fun. There we go. All right, this is going to be number 1 on the packet, but mine is wrong. Number 1 in the packet is 2 over x plus 3 minus 4. Love that. Okay. There we go. Now it matches. Now it's number 1 in the packet. 2 over x plus 3 minus 4. Got it. So first things first, we're going to play match them up. We're going to find our a, we're going to find our h, and we're going to find our k. What is our a value? 2. What is our h value? It will be negative 3. And what is k? Negative 4. From that and that alone, what we can do is we can find our asymptotes. And we can name our transformations. What does an a of 2 do transformation-wise? Stretch or compress? Stretch. What does an h of negative 3 do? And what does a k of negative 4 do? Down 4. So using what we did yesterday, we can actually get our asymptotes from just this. Our vertical asymptote is x equals h. So x equals negative 3. Which means on our graph, at x is negative 3, we're going to put a vertical dashed line. I totally wrote that in the horizontal asymptote spot, and that is in fact our vertical asymptote. Oh, it's because they're reversed on my page and on your screen, and on the screen. Love it. So be careful, because I have my screen in a different order than yours. So much fun. Our horizontal asymptote is at y equals k. So y equals negative 4. So when y is negative 4, we're going to put a horizontal dashed line. This is where we do our weird thing we started talking about with our graphing yesterday, where I'm going to say it's positive, negative, positive, negative. And we're going to put pluses and minuses around the corners of my graph. And then we're going to say, is our a value positive or is our a value negative? Positive. So we are going to circle the pluses. I'm going to use this one and this one. And we are going to physically cross out up to our asymptotes the negatives. We're not using them. We are not in these pieces of the graph. Up to the asymptotes. Our graph should only exist in the blank spaces. We've cut down half of our plane, so good. where we need it to be. Then we're going to take our A value to do our dots. This is where we're going to start at our intersection. We're going to go up, down, left, and right, and then in 1 by our A value. So we're going to start at that intersection where our two asymptotes cross. And we're going to go up 2, 1, 2, that's my A value of 2, and then into whichever quadrant I can. So we have a dot right here. I'm going to start at my intersection, and then I'm going to go down by my A value. Down, 1, 2, and into whichever quadrant I can. That's why we cross out first. We're going to start at our intersection, and we are going to go left by our A value. 1, 2, and in whichever quadrant I can. And then we're going to start at our intersection, and we're going to go right by our A value. So right 2 this time, and in whichever quadrant I can. So see, this is how it works a little bit better than it did with 1. With 1, it was a little confusing. When our A value is not 1, it works a little better. I'm going to switch my view so you can actually see the dots. That's where our dots are right now. To draw our graph, we go through both dots and hug the wall, hug that asymptote in both directions. You should wind up with 2 swoops with 4 arrows. You need to make sure you get arrows on each end. 2 lines, 2 swoops, 4 arrows is what you need for this shape. It should look like that. Then we're going to talk domain and range for a hot second. What might our domain be here? Which x values work? -2 does work. -1, +1, -2 through infinity. Does it only work -2 through infinity? Does it only work over here? Or does it work over here too? Really? I've got an arrow that goes this way. I can keep going. Yeah, it's going to be all real numbers except one specific one. Which one x value does not work? -3. So our domain is all real numbers. I'm going to switch pens. All real numbers except x equals -3. You can also write this as another x not equal to 3. All x's except x not equal to 3. -3. Gosh, I'm bad with science today. How about our range? Which y values work? Which y values work here? So I've got an arrow that points up, and I have an arrow that points down. So it's a very similar vibe. It's going to be all real, except where y equals -4. And again, you can also write this as y not equal to -4. And you have just graphed your first transformed hyperbola. Domain and range aren't going to come up a zillion times. but it's good practice for us to identify them. And you can just write it this way. This is plenty for me. I'm happy with that. So let's look at the second one. Yeah, this is number 2. We're going to do A, H, and K. What is our A value? 1. What is our H value? 1. And what's our K value? 3. So what's our transformations here?
Stretch.
Is there a stretch? Is there a compress? My A value is 1. Does that do anything to it? Basic. It is the basicest of basic. So there's no transformation on my A value. How about H? What does that do? Right 1. How about K? Up 3. So our asymptotes, our vertical asymptote, which remember mine are in the opposite order of yours. My vertical asymptote is x equals what? 1. My horizontal asymptote is y equals 3. So we're going to draw those on. X equals 1. Gives us our vertical asymptote. Y equals 3 is our horizontal asymptote. And we're going to do our weird thing where we put our plus, minus, plus, minus. Fix this one because it looks like a caterpillar. There we go. That still looks like a caterpillar. There we go. All right, so is our A value positive or is our A value negative? Positive. So we're going to use this side and we're not using this. We're going to cross these out. Ow, it's going to still caught my hair. Then we're going to take our A value and we are going to go up, down, left, and right, and in 1 by our A value. So we're going to start at our intersection, and we're going to go up by our A value. So we're going to go up 1 and in 1. It's going to give us a dot right there. We're going to start at that intersection, and we're going to go down by our A value. So down 1 and then in 1. We're going to start at that intersection, and we are going to go left by our A value. So we're going to go left 1 and then into whichever quadrant we can. So we wound up with 2 dots stacked on top of each other, and that's okay. And then we start at our intersection again, and we go right by our A value. So right 1 and in 1. So again, we wound up with 2 dots stacked, and that's okay. When we connect these up to draw our graphs, we're going to go through our dots, which they happen to be stacked, and then we hug the wall on both sides. Remember, we need 2 lines, 2 swoops, 4 arrows. It's really important that you get the 4 arrows on there because that means we need all of our swoops. What is our domain here? which x values work? All real numbers except x is 1. So we're going to say x cannot equal 1. Other than that, we cool. As long as x does not equal 1, the domain's good. How about our range? All real numbers except for where y equals 3. So y cannot equal 3. Other than that, we good. We've now done 2 of these, and I want to see if you guys have any questions. Okay, because I definitely want us to get to 3. And then I'll probably give you time to work on homework and stuff, so I don't think we're going to do all 5. But I definitely want to do 3, which that is definitely not number 3 in the packet. That is not number 4 in the packet. Oh, I love it. None of these actually match what I have in the packet. That's fantastic. We're going to do number 3 from the packet. So I'm going to rewrite this. Okay. Love it. All right, so we have y equals -3 over x plus 4 minus 1. So what is our a value? -3. What is our h value? 4. Careful. -4. It's going to have that opposite sign of right here. And what's our k value? -1. So watch for signs. H always has that opposite sign. So what about our transformations? We've got a bunch here. Has a stretch. What else we got? 3 more. Left 4. Yeah, we've got that reflection. And down 1. So I'm going to switch the way I write my asymptotes so that it matches what you guys have on your paper. So my vertical asymptote is x. X equals what? -4. My vertical asymptote shows our horizontal transformations. We're going left 4. Looks like this. My horizontal asymptote, y equals what? -1. So when we graph that, y equals -1 is right here. Now we're going to put our plus, minus, plus, minus. And is our a value positive or is our a value negative? It's negative. -3 is our A value. So we're going to actually use this one and this one and cross out, that's not black, this quadrant. We're going to cross out the positives. We're not using them. Same thing down here. We're not using them. So then our A value is 3. So what we're going to do these transformations, we're going to go up, down, left, and right, and in 1. So starting at that intersection, using that 3, we're going to go up 3, 1, 2, 3, and then in whichever quadrant I can. This guy's all blocked off, so we've got to go this way. So we're going to have a dot here. Except that was miscounted. So 1, 2, 3, here. Then we're going to do the same thing. We're going to start at the intersection. We're going to go down 3. 1, 2, 3, because my A value was 3. And then into whichever quadrant I can. I can go in that one. We're going to do left now. So start at our intersection. We're going to go left by that A value. 1, 2, 3, and in whichever quadrant I can. So we get right there. Starting at that intersection, we're going to go right that A value, 1, 2, 3, and in whichever quadrant I can. We're going to connect our dots and hug that wall. 1 arrow, 2 arrows. 3 arrows, 4 arrows. 2 swoops, 2 lines, 4 arrows. Last piece on this, we're going to do domain and range. What is my domain? Yeah, ooh, my screen's freaking out. All real numbers except where x is -4. So x cannot be -4. How about for our range?
All real numbers except -1.
Yep, all real numbers except where y is -1. So y cannot be, here we go, -1. My screen is freaking out, so it's going to look a little weird there. Okay. So there's 2 more in your little notes packet that you can do. Honestly, I would rather give you 10 minutes to work on the worksheet until announcements. So I'm going to pass out the little worksheet.